Okay, so on this sheet, all right, everybody quiet, especially over here in this particular vicinity. All right, so there are a lot of applications for what we are doing with literal equations. The main thing you're going to see is in science classes, you might be given formulas in science, E equals mc squared, whatever, you're dealing with. Distance equals rate times time. And for whatever reason, you might need to solve that equation for a different variable. So we are not going to spend a ton of time with this or look at a ton of applications with it because we are short on time. Because there will be complaints that this is not applicable because it's just a bunch of letters. I will tell you that my husband in engineering school said that there were two things that he used the most. One was converting units like miles per hour to feet per second sort of stuff. And the other was solving literal equations, being able to take a science formula and solve it for a different variable. So there's a lot of areas where you might end up using this. However, I've not really given you these in context, so they may seem a little like just not applicable to everyday life. Imagine these are actual like science formulas. A few of them are. Most of them are not. Most of them are just sort of made up formulas here. But if I give you ones that are actually science formulas, we got to spend a lot of time doing some background knowledge and stuff like this. And this is good to know, but not like our main focus for this unit, so I don't want to spend too much time on it. So let's look at number 1. You've got P equals I R T, and then in parentheses over here at the side you've got T. And so whenever for this worksheet, that means solve for that variable. So solve for T. That's what the question wants us to do. So every bit of this is like problems we have already done. We want to get this T right here by itself. Okay? To do that, we have to use opposite operations. The difference is we're not going to be able to actually do whatever we are saying that we're doing because we don't have numbers. We can't divide by, a number because so our answer is a formula. We won't get a number answer, right? Yeah. So right here, all of this is multiplied together. I times R times T, right? If they're all next to each other, it's just I times R times T. So if I want to get rid of this I and this R, I could divide by I and R. And over here on the right-hand side, the I's will cancel, the R's will cancel. It will leave me with just a T over here. Now, P, I, and R, those are not like terms. They're all different letters, right? So there's nothing I can do over there on this side. I like these problems because you can't mess them up by, forgetting a negative or saying that 2 minus 3 is 7 or something like that crazy. Because this is your answer. Because right now, T is by itself, and it equals P divided by I times R. You just leave it. That is your answer. If it is more common, like if it's multiple choice, they will probably put the variable that has been solved for over on the right-hand side and put the P over I times R over here on this left-hand. They'll put the T on the left-hand side, the P over I times R on the right-hand side. So this is probably what you'll see if it's multiple choice. And if you're seeing one of these on the test, it will be multiple choice because you'll take it on Canvas, and I can't have you type it in because it would be way too hard to type in. So it's still it's just solving equations like we've been doing. Your answer, though, is a formula instead of being a number answer like we've had before. So let's get down to number 5. We've got x plus y over 3 equals 5, and they have asked us to solve for x. So x is the variable that we're trying to get by itself. Now this one has a few numbers, so we are going to do a few things with numbers. Alright, so if we are trying to get that x right there by itself, Anya, what would we do first? Multiply by 3. Very good. We multiply by 3 on both sides. It will get rid of the 3 over here. We will have x plus y equals 15. We could actually do that, right, because those were two numbers. Okay? Then, Anya, I'm trying to get rid of the plus y. How am I going to do that? Subtract. So I will subtract y. I can't actually subtract y from 15 because those are not like terms. So I just leave it like this, 15 minus y. And that would be my answer. Okay, questions so far? All right, let's try number 8. 8, we have A equals H times B plus C. And they tell us to solve for B here. So we are trying to get rid of that B. What do you guys think we should do first? Distribute, okay? So I'm going to distribute this H right here. So I've got A equals, I'm just going to call this BH plus CH. Or if you call it HB and HC, that's fine also. A lot of answer keys will put things in alphabetical order whenever you've got letters. But we can't actually multiply them together, but if we write them next to each other, it means that they're multiplied. Okay, so we're trying to get that B by itself. What do you think we could do next? We're going to minus that CH. Right, it's separated by the plus sign, so we could subtract the CH. So it would look like this. We're trying to get the B by itself. So we are trying to get everything away from the B. So we subtracted that CH. We could add CH, but it would just move, it'd be like take us backwards if we did that. So we want to get rid of the H. It is multiplied by B because it's right next to the B. So we would divide by H here. So we'd have A minus CH over H. It doesn't because because this A is separated by a minus sign, so you would have to divide the A and the CH there, so it will not just cancel right there. If they were all multiplied together, if it was like A times C times H, if you didn't have any plus or minus signs, then you could cancel it. Okay? B is by itself, so you are done. That's your answer. It might be written this way, B equals A minus CH over H, like that. questions?
So if it's just using, I've noticed that if we're just using letters, like in the first one it says T equals PIR over P over IR, and then you have P equals whatever that was there. Would it always be like that? Or will the variable that you're trying to get to equal?
Yes. So whatever, so like on all of these, so Ian was asking, will your result always be like whatever variable you're trying to get to equal to something? So that, yes, because you were solving for that, you're trying to get it by itself. So like, if I look at number 12, I don't know what the answer is just looking at it, but I do know it should look like x equals something, right? Probably x equals something that has a y in it somewhere because there's also a y in that problem. So let's do number 16. A equals R over 2L, and it asks us to solve for the L. All right, so you may want to make yourself a little note here. You can not solve for a variable if it is in the denominator. Okay, so the L that we are trying to get by itself right now is in the denominator of that fraction. We can't, well, maybe we should put right now. You can't solve for a variable that's in the denominator right now. So I can't solve for it just like it is right now, but I could get it out of the denominator, right? Because denominators really are just like R divided by 2L, correct? So I could, in this case, multiply both sides by 2L, right? So if you have a denominator and the variable you're trying to solve for is in that denominator, you can multiply both sides to get that variable out of the denominator. Yes, it will not be our only step, but it's just our first step. So we've got 2LA or AL, doesn't matter what order you put them in, equals R if you do that. So now our L is not in the denominator anymore. So now we can solve for it. Does that make sense? So our L is right here. 2A and L are all multiplied because they're all just written right next to each other. So how do I get rid of the 2 and the A? I will divide by 2A. If I do that here, I must also divide by 2A over here. So L equals R over 2A. And so L is by itself. We know we are done. Okay, so we are going to spend about 15 minutes practicing some of these, so I want you to do as many as you can in these next 15 minutes. I'll be surprised if you get the whole worksheet done, but maybe some of you are really good. But we just want to get a little practice with some of these. You will not see, I'm thinking you're going to see one or at the most two of these on the test tomorrow. It's not going to be tested heavily. So go ahead and try some of these. You're solving for whatever variable they have in the parentheses over there.